Hi, good afternoon. Hi.
Hello, Ram. Hi. Hi.
Uh, you're just coming from other meeting, maybe Anil and Drew will join.
Hey guys,
Hello.
hello, happy Friday.
Happy Friday.
I think all Friday meetings are dedicated to OCP.
I
Like
know.
3 meetings, I think, other CLA work streams, 3 to 4 meetings with ecosystem partners.
Right.
That's all?
In Friday and Fridays, Drew.
Oh, just on Friday. Yeah, sure.
Yeah.
I know. It's like a no meeting day, and it's like an extra meeting day for me.
Yeah.
Oh well, it's good. So,
Okay.
Anil, I worked on some of the picture stuff today, and it looks like Suke did follow up in his action items.
So,
So
shall I
maybe,
start sharing?
sure, I've got it up either way. That doesn't matter to me.
You can share. That's okay.
Okay, it doesn't matter to me. I'm happy to do it. I got it. Okay, as soon as it pops up. Um, let's see. Sorry, it's really slow. Okay, did that come up?
Yeah.
So I don't know where we want to start. I think just as a reminder, we did go through the drawing. We made changes in the last meeting, and I thought we kind of landed where we were going to land. Um, and with that assumption, I went and documented things below. I copied the picture to other places. So like to the in-band picture, I just made the in-band picture and grayed out the with the new drawing. And then Suke also followed up on his action items. So where do we want to start? Do we want to
So we
start?
can delete the original in-band drawing now, right?
I think so. I didn't want to do it without reviewing it. So I just took this drawing and grayed out all the out of band stuff. Um, and so it's otherwise the same.
Yeah. I think that this makes sense. So
Okay.
unless somebody has any other suggestion, let's
I think you're
delete
the
that.
one I wanted to hear from you that it was okay. So that sounds good to me.
Yeah. I'm glad that you did it because you gave me an action item to do it.
Oh, that's funny.
I,
Oh, okay. Well, good. I hope you don't mind me doing it. Um,
Thank you. Okay, and I moved the PCI section right after that. I do need to add a paragraph here, kind of set the stage. Okay, why we are putting that here, which I haven't done that. So I'll do that. Basically, I want to add 1 or 2 sentences to clarify what we discussed last time. That as an example, um, in the Linux environment for PCI error handling in ban. Following is an example of how PCI errors can be handled through in-band method, and then kind of describe that.
okay.
Hello,
So
can you hear me?
yeah, yep,
So, I think we have had some, kind of discussion about PCIe, how to use that, how not to use that. But at the very least, I think we need to identify that PCIe is as a name is registered, whatever is a proper term to highlight. It's owned by the PCI SIG. So we need to recognize that at the very least. And then I think before we contribute this, we should make sure there are no objections to it.
yeah. We
Because
discussed that. We didn't take any specific action item on that, so that's a good call out. So typically, whenever we use PCIe terminology, we put an asterisk there. And I think if that's what you're suggesting, we should do definitely we should do that, and then put in the footnote somewhere clarify
And
what that.
this reference goes to the reference, right? It's not in this section. We just refer to it like as a reference, not the direct link here. Who wrote this paper? Error handling in kernel, whatever this PDF is.
This is the one we reviewed. You remember we had the prior discussion that the PCI SIG was concerned about, and we got their clearance and wrote this paper. And this is John Pando's paper.
Right. Yeah. Okay. I know that one.
Yeah.
Okay. So yeah. Yeah. We should put that in the reference.
Yeah. I think that's a good point. I removed from here and rewrite these paragraphs so that I just embed the reference in the discussion rather than actually adding a reference here. So
Well, there's also a references section in the end, right? So I mean, it would be good to add there, right?
that's what I think. What you guys are suggesting to add there.
Yeah. Okay.
And remove that explicit reference call out here.
I mean, we can have a link to the paper too. It doesn't hurt, but yeah, right here, I see what you're saying. Yeah.
Yeah.
Well, but so I gave you those action items. I hope you don't mind.
Yeah.
Drew, your previous comment about PCI on that should be a footnote on the first page where it's first called out. So it should be a footnote on that page, not in the reference, right?
Oh, I'm sorry,
Right.
I misunderstood you. I'll edit that.
And also, I think one of us should take an action item to reach out to the PCI SIG and discuss, present our intent and get their blessing or feedback or whatever.
Yeah,
right?
definitely send it for their review before and say call out that hey, we are doing this, so we don't want any backlash after we contribute it.
Right. And Yogesh, I'm not sure if you were there last week or not. We did discuss this, and one thing I made the clarity that all the references we are doing here is in the context of this John's paper, and this is a Linux community interpretation of the spec. And it is all in public.
Right, to support the spec, yeah.
Right. So we are not explicitly calling out the spec itself.
You don't have to convince me, Anil. You know that, right?
No. That's why I want to clarify.
No, I wasn't there last week, but I was
okay,
there
okay,
last
okay.
week. But we still want to do our due diligence, so we don't.
Sure.
Absolutely. Yeah.
Why not? Yeah.
Yeah. Yeah, it's better to check, double check or triple check rather than make an assumption here. Yeah.
I think that the PC error handling in kernel, that will be very useful for Microsoft, especially to see where we are. And thank you for putting together.
Yeah, good point. I know that.
Yeah,
I know exactly.
I was thinking that too, Ram. I've started showing that to some folks inside Microsoft, John's paper. But yeah, maybe you and I should take the action item to work on that internally. Yeah.
Yeah.
And
I put
by the way,
like some things before. Yeah, I did.
And this spreadsheet is useful, and I want to come back to it, but not now. But yeah, this is good stuff. We're not done.
Yeah, for some reason this figure got omitted. I don't know what happened here. I'll try to fix it.
Oh, I don't know. I didn't.
Maybe when I did the edit, I was not in the editing mode, and I messed up, I think.
You know what? Google Docs was doing some weird stuff to me, and I had to leave suggestion mode and go into editing mode to paste the pictures right.
Exactly. I think I messed up in that, I guess. So let me.
I had the same problem. Yeah. Okay. Do you have a copy of that drawing somewhere, or is it just one version?
No, it was in the document. I have to go back previous version.
Okay.
Let me see if I can fix it now.
Okay, I'll let. Maybe while you do that, I think we've already reviewed a lot of this. What we should probably do is let you add your introductory. Oh, that's weird.
Yeah, no, I'm just doing it right now. Bear with me. I'm undoing it.
Oh.
Hopefully that will bring back.
I'm going to be hands off while you do that.
Yeah. So I think now I see the drawing. And sorry.
Oh, that was we lost. We had heard a weird sound from your speaker, or from your voice. So I mean, maybe when we're done with that, we can go. Is Suke here today?
Okay, I think I got it now.
Oh, you did. Yeah, I see it.
And now we can safely remove it.
Sounds good.
Okay. Now we've got. You can add the comment, or I can add a comment for myself.
What happened? Oh, the comments got deleted. That's weird.
Yeah, because I had to undo it.
Oh, so here's what here I'll see if I can go forward. So in the future, what you can do is go to File, Version History, look at a previous version, copy the picture from that previous version into your clipboard, and then go exit looking at previous version and paste in. I thought that's what you were doing.
Okay. Next
Let's
time
see.
I'll do that.
It's easier, yeah, it's easier just to go here and look at the version history and do it there, I think. But okay, that worked. But you'll have to add your comments back. Okay, so I'd like to look at what Suke wrote and get it cleared up. So okay, firmware first. Adding the is just good grammar. I'll accept that. Okay, Suke defined device firmware. So can we just, if you don't mind, I'd like to just get Suke stuff checked off.
Sure.
So any comments on device firmware, or can I accept it?
Now, one thing I want to, something I learned that in the block diagram, right, we are showing one box as device firmware, and it is within this kernel, within the software stack, right? But the implementation can vary a lot. Can you go up?
Oh, you mean this?
Yeah. So yeah, the description that we were just reviewing, right, is in the context of this block diagram, right?
Okay.
So the device firmware, the way it is shown here, this is a very abstracted, very simplified block diagram. Okay.
Yeah.
In reality, the device firmware implementation could vary a lot.
But how would it, like, I guess, so when I think of device firmware, I think of firmware that runs on the device. I mean,
Which
maybe
the description doesn't say that. So I was going to ask that question. It could be read as running, on a host. I don't think it's intended, but I think that's a good clarification.
Yeah, so that's right. It could be partly on the host, partly on the device, right?
If it's on the host, is it really firmware?
well, you're talking like a boot option ROM or something?
Yeah, so that's where, so so when we are when we're saying device firmware, we should call that out, that this is the part of the device handler, you can call, a device driver, that is controlling the hardware itself, or maybe
But like Anil, this is what I don't understand. Like when I've worked on, I worked on I/O devices like video transcoding accelerators, and it had device firmware that ran on the PCIe card. There was a, there were microcontrollers embedded in the device, and they ran firmware.
Yeah, actually, sorry, I made a mistake. I meant to say about device driver. Device firmware, I don't think there is any confusion there. Device firmware should be, I mean, by definition, firmware is something which is really
It runs on the
sitting,
device, right?
yeah, it's sitting on the device, right? It doesn't
Okay,
come in a
okay,
form
good.
of flash, right?
I'm breathing. That's where Dean and I were a little bit confused, I think.
Yeah. Sorry. Device firmware, there should not, I mean, the description I see, let me read through. Device specific firmware controls, manages endpoint devices. Yeah, I don't see any problem here. Does anybody have any issue with the device firmware?
Well, Dean was suggesting we might say it runs on the device.
Controls and manages endpoint devices.
I mean, could we just say, I'm gonna make a proposal, and if you don't like it, I'll undo it. But runs on the device, and
That's okay. Yeah.
well, to control, I would say, so we don't repeat and to control and manage endpoint devices. So, I mean, Dean, I think that's kind of what you were saying, right? It would be good to say it runs on the device.
Yeah, I think it's important. So I think your update is good.
Yeah. My actually comment was about the device driver.
Oh, okay. Now you're making more sense. I'm gonna accept this. Let's look at the device driver.
Yeah.
As long as Suke doesn't have a problem with a change.
It should be fine. I mean, he's actually on vacation today.
Do you want to say endpoint there in the first statement?
Right here, I think so, don't we? PCIe.
I mean, devices are endpoint, right?
Endpoint.
I mean, endpoint is not necessarily to be called that out here. Just devices good enough.
That's what I'm
devices,
saying.
Right?
Yep, that's what I'm saying.
Yeah.
Okay. That's fine with me. I'm not particular.
Yeah.
Okay. Now let's dive into the device driver.
Yeah.
So what were you saying? Yeah,
yeah. All I was pointing out for device driver is that the way we are showing in the block diagram, it's a very simplistic view of device driver, part of the vendor code, and part of the software stack above the firmware, right?
Mm-hmm.
Basically, it looks like device driver is part of the software stack running on the host, right?
Well, isn't it?
Well, that's why I wanted to kind of clarify that it doesn't have to be. Some part of the device driver may be even sitting on the device itself.
But isn't that device firmware?
Not necessary. That's where the lot of implementations. It's a very implementation specific now. Becomes very implementation specific. So we just want to be acknowledging that this is a very simplified block diagram. The implementation may vary.
That's fine with me, but I want to make sure I understand you because I don't quite. So are you imagining like you have a device driver and the device driver comes up and says, "Oh yeah, I see the thing I'm managing," and it puts some software on the card to run? Is that what you're?
Yeah, I mean the card may be full-fledged CPU with its own kernel and device drivers.
But that's
right
still
on
a
there.
device driver. I mean, it's still a good device. So even if you have let's say that you have an embedded CPU on a PCIe endpoint and it's running Linux.
Yep.
That's still device firmware. I mean, like if you have a router that runs Linux, like there's little routers people like to load Linux on, that Linux image is firmware, even though
Sure.
it's.
I mean, again, this is where the terminology thing can change, right? Depending upon if you look at from a software point of view, it appears like a driver. But if you look at from a system point of view, it looks like a firmware. But it is actually running on top of the kernel, which is embedded within the device.
I've never heard of that described as firmware before. I mean, it's fairly well-known traditional paradigm that a device driver runs as sort of an extension to the operating system and is device specific. It's
Yeah.
part of the
And
software stack.
if you have an OS on your endpoint, the thing that you're managing, like a PCI device, that's just firmware. But I don't know. What do you want me to change? Like let's look at your proposed change exactly and see if we can understand it. Like what do you want?
I'm not saying to change anything. I was just brainstorming in my mind and trying to clarify that the device driver scope shown in the block diagram and what we're describing here is a very simplified view. It's not covering all various implementations. That's all I'm trying to make that. Because somebody can argue and say, well, why you are showing device driver only from the host point of view? A device driver could be completely self-contained within the device itself. And the device is communicating with other devices and is not even discussing, not even interacting with the host.
Okay. Well, then you don't have a driver for the OS in that case. You just have firmware.
Yeah.
I mean, yeah. I think part of the confusion is like a driver is typically running in the OS on the host, but is also like delivered as a separate software package.
Yeah.
Firmware is typically delivered, like on the card and is running on the card. But
Correct.
like those two properties don't have to go together, right?
Yes.
Right. Like, so you could have something that's delivered as a driver, but then is running on the card, right? But I think this is generic enough that we just leave it, right?
Yeah.
Okay.
As long as we are on the same page, I'm
Yeah.
okay. I just want to call that out that we shouldn't get into this rat hole in the future, unless you want to make it clear here so that we don't get into the rat hole. Sorry, if we get into that hole, we say, okay, this is how we are describing it.
Yeah, I think it's clear, right? Like the description says is where it runs, not how it's delivered, right?
Mhm.
So
Yeah, the intent of the driver, right?
Yeah.
There are software drives in all. Yeah.
Yeah, and what it does, it abstracts the hardware from the OS. It's abstraction layer. So like that makes sense to me. Okay, well I'm going to accept this then, and I'm going to delete this. Okay, that's awesome. So that's looking clean. And then you saw this. Anil's got some stuff to do here. Let's see. Oh, and last week we said that we need to check the addition of the IMA with John Panda. I don't think it's going to be controversial, but it'd be good if you could still check in with him.
Yeah.
And then last week I just wrote this down, but I think we talked about this. I thought you were going to do this. Does that make this more obvious to the big drawing? Is that controversial with you? I mean, I think you can just explain this is the in-band, path for gathering errors, and that we're
Yeah. No, that's a good point. I will redraw this little bit so that it actually gives the notion that this kernel space and user space is the expansion of that little block diagram on the top.
Oh yeah, that's a good call. Okay.
Right.
Okay, I'll leave that. Let's see. You added paragraph. I'll accept that. Okay, we've reviewed this. Now, I made some changes to the text below, just to make it line up with the drawing better, but I don't love what I did. So if you hate it, we'll change it. But I called it out-of-band support, because like the RAS agent is kind of hardware, but it's whatever. It's firmware, it's software, it's hardware, it's whatever. So it's really support, not hardware. Each hardware components provide out-of-band error log capabilities. So hopefully that's okay. If it is, anyone push back on support? I'll accept that. Okay, since we made it more explicit where the RAS API agents go, this is called vendor code in OpenBMC, and it previously referred to a box here. But I think the key is we have a RAS API support in the BMC. And each component vendor provides interfaces that enable this, enables to discover endpoints, configure RAS features, log errors, and trigger RAS actions. So I'll sit right here for a second and let you take a look at what I wrote. If you have any concerns or changes you want, I'm happy to make them. Or if you're Dean, you can just make the change. I'm joking because I saw Dean's cursor, which is fine. Okay.
I don't see a problem.
No, I'll accept the first section. Okay. I said which includes initiating RAS actions. There was a trigger RAS features block in the previous drawing, and we abstracted that out because we previously had something in the analyzer that said trigger RAS actions, but I think we cleaned it up substantially just to say the analyzer takes CPERs in and CPADs out, so there is no trigger RAS action block anymore. So I just deleted that. So hopefully that's not. And then I mentioned, error logs collected in band or out of band are expected to be CPER. RAS actions sent back to the RAS API are expected to be CPAD. And then I had an action item to document the dotted line between I'll show you the dotted line real quick. This dotted line, I had the action item to document. What is it for? And so, in my opinion, I think the analyzers can pass hints to the OS. And like I've talked to the Windows team, for instance, and they want to, if there's something that they need to know about, they want to see it and act on it. And so, if we know that there's a page that's like a page of memory that's suspicious, even if we haven't seen an error, it's still useful to tell them about it. So that's my assertion, is that I'd like to be able to pass RAS actions back to the OS. And even on bare metal machines, it might work, because if the OS just has built-in support for these actions, when it sees the action come to it, it'll just do it, and I don't have to put an agent, and that'll be really beautiful if that happens, because now we can even cooperate with bare metal OSs to take some simple RAS actions within the OS. There also may be value passing data from the OS to the out-of-band fault management tools, but it's going to require us to look carefully at that to ensure that the OS never passes PII or customer data to the BMC. It's just a security concern that we would have to overcome. So I don't know. I'm happy to get feedback on this. I don't necessarily love this, but it seemed like it was worth mentioning, and I did have the action item, so that's what I was thinking. So is that contentious, or can I accept the change? If anyone's talking, they're on mute. So I'm going to go ahead and accept it. But if you have concerns, go ahead and put comments in, and we'll deal with them. I'm like I said. This section probably could be clear. I was just doing a little bit of cleanup. Okay, so if I scroll down, this is already, we had discussions about it. One thing, well, Anil made these changes, so we'll get here in a second. I just want to show you one other thing I did, is I took this drawing and put the new drawing in and moved the boxes around, but it needs work. And the other thing we need to do is, so we had some other flows that we said that we wanted to put in, crash dumps and PCIe corrected errors. So maybe, do we have volunteers? Are these the right scenarios? Volunteers?
So that flow was my drawing. I think I can take. Yeah.
That'd be awesome.
but we need new owners to draw this next two. No, not this one. The previous one that you moved the boxes around, that was the one that I drew before, 13, right? Yeah, so you can put my name to that. There are two we need owners, new owners.
And I did put the new drawing in. I just didn't delete the old one.
Yeah, thank you. You did the heavy lifting. Drawing is the hardest part.
Well, all I did was I went into this drawing and copied all the circles and pasted them, and a lot of them were almost in the right place. I just had to, you know, well, it wasn't
You
that hard.
do them wherever they stick, right?
So,
I'll take that.
okay, if you can make sure I got it right, that's great. So then, and Neil, I want to get to the stuff you did, but I'd like to assign some names. Well, let's make sure we have the right flows here, you know, that we want to walk through. I'm happy to take one of them if no one else wants to, but do we have any other volunteers? Okay, in the absence of volunteers, I'll take the next one that comes up.
Like this crash dump flows, right? It's already described in other spec, right? We want to go depth to it.
Well, I think we need to show the other spec hasn't been seen by everyone, and yeah, because we're still writing it, and I think we need a more general one that is
Okay,
more.
I can work with you, and you can put my name. Yeah.
Okay, I'll put. Oh yeah, I can. I'm happy to work with you on that. That sounds great.
Yeah, because I want to make sure like we're not duplicating other. That's why once I
I don't. I think we just want to make them the same. So you and I.
Yeah.
And this is this is like I view this as kind of the overarching drawing or overarching doc, and then everything we're doing should, fit into the scheme we have here. And so, and it does. We haven't done anything really that elaborate. So yeah, let's do that. Okay. So that's good. We got owners. I'm going to scroll back up now. I think the next thing is this section, and it looks like Shibata, Anil, and myself owned it. I have not done anything to it, but it looks like Anil has. So, or maybe not. Maybe you were taking a list of things that needed to be done.
Yeah, so this block diagram, I did not put it. I'm assuming Shubhada did it. I'm not sure. This diagram?
I don't know. I did not do it. I don't think.
Is Shubhada on the call?
Yes.
Shubhada, is that something you put together? I think you'll mute. Or did we lose her?
Well, and these are the flow examples. So, I mean, I think I took the out of band one and the crash dump one. I mean, Rama and I can do these two. We took them down below. Persistent correctable error, rate limit versus aggregation. Yeah, I can do that one too if we need to. But it might be good to do a PCIe corrected error using in-band. But I think that one is more you, Neil. I'd put your name here if that's okay.
Well, I mean, that actually, that one I already captured as an example in the previous section, right? So we can just cross that out.
Yeah, that's true. Okay.
And out of band would be a good one to contrast.
Well, I've already taken the action item just a moment ago because these are listed down here at the end. See so I took this one. Rama took this one, and
Okay,
so
good.
I mean, if someone else really wants to do it, it's not, people just weren't leaping out. And the persistent corrected errors, I mean, that's one that I'm passionate about, so I'm happy to do that one too.
Now this is for in band, out of band, or both?
I think it's both.
So this is a
Just
good
a
one, by the way. This is a
fair
good one.
warning,
And
Drew, you might have to count errors for that one.
I'm sorry.
You might need to
so
count errors for that one.
yeah, so persistent corrected error handling is a very interesting one, and I would say the least understood in the industry. So it'll be good to kind of share the thought process of what are the methods, techniques. First of all, why we care for persistent corrected errors, right? And what are the techniques can be used as a high level guidance, and then leave it there because
Yeah. Well, I mean,
right.
and that's where rate limiting comes in and tuning your pipeline for the rate limits that you have in place. So,
Yeah, rate limiting is part of it, Drew. I mean, there's quite a bit of thing, right? First of all, again, I'm just brainstorming, right? If the implementation is interrupt driven, interrupt based, right? Then the whole flow need to be thought through, right? First step is disable the interrupt. Then second step is go into polling mode. Third step is to apply some sort of rate limit.
well,
Right?
but Neil, you can also have rate limiting in hardware. So you don't even have to change from interrupts. If I have a rate limit that says, when you show me a corrected error, don't show me another one for 1 second, and I've set my software up to take an interrupt once a second with tolerate that, then we're done. The hardware does 1 per second and you're good. So I agree that there's a lot.
But there's a problem too. Again, I don't want to go into too much detail here because let's say the error rate is 0.5 per second. You will never see that. And that means you don't have
No, wait. Rate limiting is not leaky bucket. Leaky bucket is bad. Rate limiting, you see the very first error. And if you're saying it happens twice a second, then I don't care.
half a second, yeah, or rather 1 in every 2 seconds.
Like we did a study with the memory vendors, and a representative sample of corrected errors was fine. Having the total count is good, but
what I'm saying is that the moment you apply some rate limit in the hardware, right? Either you have to be very aggressive, otherwise you will miss out certain type of error rates which are just below the radar screen.
No, you still see them. So it's not below. If you have a slower rate, let's say that I have
That's what I mean. Slow, yeah.
If I have 1 error per week, that is exactly why I want rate limiting, because the first corrected error happens and it gets sent immediately. But then we don't send another one for 1 second. But that's fine because the second expires, we haven't had another error anyway. So a week later, we get another error, we send it instantly. That's why I hate leaky bucket. But rate limiting is great because you see the first error. You see the low
Bucket
error.
has its place, right, for storms. Leaky bucket has
No,
its
it
place.
doesn't. It does not have its place. It is
No,
bad.
not for persistent, but for burst of errors, right?
No, even for burst. So the problem is leaky bucket hides the early errors from you. It is bad. So you can get the same thing with rate limiting.
There may be situations where you understand why those errors happen, and those are understood. You don't want to bring the system down, and that's where leaky bucket prevents the system from coming down because those are.
But I'm telling you, Yogesh, that's actually kind of my point. That is the point I really want to make here, and that's why I want to do this one. The problem with leaky bucket is that if you have 1 error per week, like Anil was saying, you drop 1 error per day, you never see any error.
That's not where leaky bucket is useful. I agree with you on that one.
No, but I don't need leaky bucket for anything then, because what it's for is for handling storms. But if I have rate limiting and I say I'm going to limit the number of interrupts I can get per unit of time, then I always get the first error and I don't see any more until that unit of time expires. It handles the storm. I'm saying we can get rid of leaky bucket. We do not need it. Rate limiting is better.
No, I don't agree with that.
I think the definition of
hey guys, sorry. What are we? I understand the debate. I understand what are we actually trying to write?
So that's why. Yeah, let's write down our terminology, right? Rate limit with a leaky bucket. Let's write it down.
Like what are we trying to say? Like, what are we trying to document? You know, our
Techniques.
someone's best techniques. Like, what are we
Yeah.
trying to document?
Yeah,
Yeah.
in my mind, first of all, we want to acknowledge that persistent correctable error is a real problem, and we require solutions to handle those. Okay, that's the first statement, and then we provide some indicators or examples of how it can be handled.
I'm not
Actually,
sure.
how
I'm
is
not
not right,
sure you
right?
should do that.
Yeah,
I
how
mean,
is not the right word, but some industry practices. Okay.
so what you want to do is throttle, and the method for throttling, there are many. You've been discussing them, and I don't think you want to go into that debate and make recommendations.
I do. I strongly, really urgently do. Leaky bucket is useless. If I can promise you, show me anything leaky bucket does, and I can do it with rate limiting better. That is actually I want to shout it from the mountaintop. That is really important.
So Drew, what I would suggest is let's write down what you meant by rate limiting, okay, and also clarify what is leaky bucket and what is not leaky bucket, right? Let's draw some
Yeah, I'll
parallels.
write it out.
Yeah, I would encourage you to write the requirements that you have in mind, and that, you know, before jumping to rate limiting or leaky bucket or whatever.
Totally agree with you. Yeah.
So is the problem here that we are trying to come up with ways to handle persistent correctable errors in memory?
It's like the
It could be memory or PCI or any other cache error, any kind of
Yeah.
correctable error, right?
And
Yeah,
the problem is you don't want to hide the early errors that happen at low rate, but you need to handle storms of it.
But Drew, you got to write down why. Okay, you just said you don't want to hide the early errors. Fine, why? Right, that's the requirement. The requirement is why don't you want to do it? That's the requirement, right? So like you got to articulate that first, right?
I can. All right, I took a note too. Yeah.
Yeah,
and
that's a good way to put it. Like, you know, let's write down the requirement. Why persistent error? Why persistent corrected error? Visibility to persistent corrected error is matter.
Yeah, I mean that's.
So I've got a question on error storms. So what exactly?
Go
ahead. I've heard this term used all the way back since I worked at Sun. And it still puzzles me what these are, because they will seem to come up and then go away. And it's like, well, wait a minute. If there's really bad memory and there's a bad bit, it's not going to go away. So these storms, when I've been told about them, they seem to come and they seem to go, kind of like real weather storms. But what is that? If that's a real hardware fault, how do we diagnose that? Or, you know, if the hardware is operating fast enough to handle the storm, do we want to even do anything with it? Why do anything with correctable errors? Leave them alone. They've been corrected.
Yeah, very good point. And I can share my thoughts, our learning. First of all, first thing is, yes, a storm could be either due to persistent fault or permanent fault rather. They'll always be there. That's one scenario. Or we would see a storm of errors and then the errors goes away for a long time. And we see both cases and both are problematic.
Well, and I can go into
couldn't that just be data access patterns at play here?
It can be. Yeah. I was going to go there. And the other thing that can happen is that radiation can strike a structure that that causes a series of corrected errors. There are structures that where like a bit flip, okay, why don't we do post-package repair at runtime most of the time? Because if we were to swap an uninitialized row into memory, you would get a whole bunch of corrected ECC errors, assuming you have chip kill ECC. So you can imagine other failures where you have a burst of errors until the ECC scrubbing corrects it. or it could be access patterns, as you said, Mita, or it can just be a hard failure. And I've seen studies where hard failures went away over time, and we have no idea why. But we had something that looked really broken,
Right.
and we just kept using it, and it got better.
So what you're articulating is the requirement is to keep the system up with minimal to no performance impact, yet expose enough information to debug why the problem is happening. Like that's your requirement that you're articulating, right?
Yeah.
Yeah.
Or implement some RAS action to mitigate the impact due to persistent fault.
Well, but
To
again,
that
just
point,
I mean,
Anil, right? Like,
the,
do we really have an action that can be taken when you see such storm of data, error data, right? That's been one of my questions. That like, what can you do when if you collected all of the error data that was lost during the storm, and you had an opportunity to collect it? Would that really help? Like, what?
No,
Because it could be
wouldn't.
because of any of the reasons, right?
Or you could offline pages.
Well, that's true, Mita, but usually you can do that with a representative sample, and so that's that's what I proposed this at FMFM, and I think Roy pushed back initially on me, and then they did a study and they found that gosh, even sampling once every 10 minutes with the historic data they were given, they could get it right most of the time. No, 10 minutes is way too long. It's not what they were advocating, but their point was that they discovered with memory a representative sample was sufficient, and so I see a bunch of errors, and I'll start seeing the pages I need to offline.
Yeah, I totally agree with that. That is something like what we actually do.
Yeah, I agree with that too. Sampling on memory errors should tell quite a bit of the story.
Yeah, and that's why I'm just saying I want early samples, and that's my heartache with Leaky Bucket is that if you have low rates of errors, Leaky Bucket hides them, and so I can show you a simple rate limiting scheme that meets all my requirements. And sure, I'll document the requirements, but I'm telling you what I've worked out on working on this is really simple. Just when you give me an error, don't ping me again for a period of time that we can set within some range, and we can control the storm. But we still get the early error, so we still get the representative sample. And that's my heartache with Leaky Bucket, is it by definition hides the early low rate sample of errors. So I think it is counterproductive. I don't feel that strongly about it, but I can show that. I can walk through that. Okay, well, this is good. I can work on that for next week. And I think that's going to be a really rich discussion. And I'd love to see if you line up with my requirements too, because I'm not, I admit that my thought here is based on just my experience analyzing memory errors and working on FMFM, but it'll be interesting to see how this applies, especially to non-memory. I think memory is more understood because memory errors are pretty common, but I'm not as confident for PCIe errors, for instance. I don't think you want to see a storm of URs, but if we're getting URs, it's maybe useful to see.
Hey, Drew, before we run out of time, I just want to make sure if you scroll up, I don't know if we already finished that part.
Well, we need to go do this stuff, but I realize, I mean, this
scroll up further. Scroll up
this.
further.
Oh,
yeah. So.
What here?
Yeah. One, maybe a little more. Right here, node view. So node view, I think this is now a little bit out of place, right? Or is it in continuation of the previous section?
Well, like we have these drawings, right? We have your high level drawing. We have the detailed drawings.
Correct.
And we have another high level drawing. And I think this is useful in that we do need the communication between these.
Yeah, Mike. Along with your explanation of the dotted line, this is what it's trying to explain, right?
That's a good point.
suggests that the visibility.
Yeah, we probably need a little more context before, prior to showing this, discussing this, so that, because I was finding it a little bit out of sequence
Well,
now.
like I did have that explanation for the dotted line above, and then this goes into it even more. That's a good point.
Oh, okay. So then it's a further
Actually, it is
continuation
in
of
the
the
right
dot.
place. Then, yeah.
No, then don't call this a node view, right? Then call this as a part of the out of band flow description.
Actually, you
I
can
don't know.
move that node views subheading. I don't think we need that at all.
Yeah, that's what I. Yeah,
It
so
goes
if
right
it,
with the paragraph above or bullets above.
You're just saying
Because
yeah,
we talked
then
about when
yeah.
we did that. Yep.
it really
Yeah.
flows. Okay, we got lucky.
Yeah, so this is a further description and illustration of the out of band flow for the clarification of the dotted line interface, right?
Yeah.
Then it's okay. Then do we need to show all other in band and OS error visibility?
What are you saying?
No, I'm just thinking loudly here that the intent here is to show when we are implementing out of band, like bare metal, how the OS error handling will be visible to VMC. Is that the context here?
I think so. I think the other thing is yeah. I mean, like it's not just one way though, right? Because we said we may need a hardware assist to write to the HEST, and so we were saying if I want to pass a message to the OS, how do I do it? We could copy it to some location, and the term I think Vilas suggested was tickle the HEST or tickle ACPI to copy it into the HEST for the OS to see it.
So just to align with the previous drawing, I think we should kind of flip this, put the OS on the left side, VMC on the right side, and then show the same context as we were drawing the pictures before, right? Just to show continuation of further expansion of that big drawing.
That makes sense.
Because I think we should have stay, right? Let me just. I think we took out the hast, so which is good, which is okay. And now this drawing will actually
This
further
drawing will
expand.
spell it out. Yeah.
Yeah. So basically, we are going to expand on the OS box, and then clarify further how this interface would look like. Again, not how, probably not the right word. What could be one way to implement, or example implementation.
Okay. And then this is the complementary flow. Let's see. So do we need to flip this drawing?
Yeah. Now integrating BMC logging and then logging. I need to read through this one. Maybe Drew, you want to walk us through like what is the thought process here?
Well, I don't.
Forgot now.
Yeah, I mean, let's see.
It's a long time. It was a long time ago. I forgot.
Well, hardware. Let's see. The OSC's error logs, right? Synchronous exceptions, machine checks, so you don't consume poison, AER. So the hardware has all these, but they've got to go here. I think this is for OS-based method. So if you're logging in, this is kind of an in-band picture, right? That if you're doing, yeah, see it says in-band here at the bottom. Sorry, integrated BMC logging and in-band logging. And so I think this is the case that we talked about early on, where you're logging through the OS with an IMA, But sometimes you've got to get stuff from the BMC because you have error logs when the OS can't run.
Yeah, if I remember, Anil, your intent was, I think you drew these tracks. Your intent was in one case in-band was primary, in the other case out-of-band was primary, but there's still visibility for the other side.
Yeah. I mean, it is like if it is a hybrid approach where some errors are propagated through BMC, some in-band, and now we need to kind of reconcile how do we do that, right?
Yeah, and I'm with Yogesh. I thought you drew this, but maybe I'm misremembering.
I think we collectively might have drawn together.
I drew this one. I'm pretty sure, but that's fine. So do you mind checking this drawing to make sure it reflects your intent?
Yeah, I think we'll do the same kind of. We'll flip this one, right, and then show.
Yeah.
Again, I think we are doing this. We are expanding on this interface between BMC and OS.
Okay, it looks like easy to flip. But I guess the question here is, okay, like this one flows straight out of that. This one.
Yeah, let me think about it, Drew. Maybe you don't need two separate drawings. One drawing would be sufficient to kind of show that how would the hybrid approach would look like.
Well, this one shows, this one is important because it shows what has to go to the OS and what could go out of band, right? Because like the OS has to see some things directly. We can't, like a machine check for poison. You've got to see that immediately, or DPC. The OS has to be involved in that. But if we're debugging and diagnosing and fixing hardware, a lot of that can go out of band. When you're doing it in band, it is different because your constraint is different. You have to send. You can send everything in band except for when in band is broken. Is basically this is the corollary to the other drawing. So I think they're valuable. It's not. It's a it's a different drawing, but it's showing what you have to do. This is what you have to do to get complete error logs if you use in-band error log. And then this is the limit to how much you can send out of band. You can't send everything out of band and hide errors from the OS. And see what I'm saying? So like each method has its limits, and I think these drawings kind of show, hey, here's how you make them work practically.
Yeah, maybe other way around to put it, if we want to implement, let's say, BMC based methods, then there are certain limitations and how we'll overcome that is shown here.
Yeah.
And if we want to do in-band methods, then there are some limitations.
The different
and
limitations.
How do we overcome that? I think that's what we kind of contrasting the two, which is a good way to kind of think through and then show that, illustrate that. Yeah.
All right, guys, is it a good place to stop? So we are kind of a minute over.
Yeah, I think we're getting there. Last section, we're right to the buyers now, right at the end. Maybe a few more sessions and we can.
Yep.
We're getting there. We're making progress. Okay, so who's going to flip these drawings? I feel like I've taken on a big one with the corrected memory errors. Is someone willing to go through this section and make sure it's clear?
I can work on this one.
Okay. You get, I'm not trying to volunteer you, but did you have a section you wanted to work on, or are you too busy?
I think I have that the other diagram, right? So let me just take care of that first. The flow, the recovery flow.
Okay, that sounds good.
Page offline flow, sorry. Yeah.
Yeah, I wasn't trying to impose on you. I just knew that you might want to take a more active role in editing. So.
Yeah, just trying to balance things, right? Don't want to just commit and not deliver. So.
No worries, no worries. Sounds great. Okay. Sorry, I can't talk and type. Okay, that sounds good. So we've got some stuff to discuss next week. we're closing things, so this is good. And then I think we need to figure out what to do with this drawing. And yeah, it's kind of an interesting drawing. I mean, it is useful because you're saying if you, but I don't know how to talk about it. But if you're talking about PCI endpoints, like if we have downstream port containment, it is better to have it, in the switch so that this endpoint still works if this endpoint triggers downstream port containment. So there's some interesting things here, but I don't know if that was what was intended.
Yeah, let's get the other flows done, then we'll come back to this one. Maybe we have more clarity by then.
Okay.
There's also looks similar. Okay, then. Good meeting. Thank you all.
Good. Talk to you next week.